Composition of functions. The composition of the function f with the function g is f of g of x, or rewritten in this way as well. The domain of f of g is a set of all x in the domain of g such that g of x is in the domain of f. So this g of x has to be in the domain of f. So let's try it out. Composition of functions. Given f of x equals x plus 2 and g of x equals 4 minus x squared, find the following. So the first thing you do is you have f of g of x. Let's rewrite it. So we'll write it as f of g of x to kind of help us set it up. So what we're going to do is we're going to replace the g of x inside. G of x is 4 minus x squared. Then we're going to take this 4 minus x squared and we're going to plug it in where we see the x in our f of x function. So now this becomes, I'll just do the parentheses, 4 minus x squared plus 2. So this is going to be 4 minus x squared plus 2 is negative x squared plus 6. So that's f of g of x. Then I'll do the opposite, g of f of x, or the other one. So we'll write g of f of x. So we will replace the f of x inside. So the f of x is x plus 2. Then we're going to take this x plus 2 and we're going to put it in where we see the x here. So it is 4 minus parentheses x plus 2, and this is squared. So now we have 4 minus x squared plus 4x plus 4. If we distribute the negative, we have 4 minus x squared minus 4x minus 4. Then the 4's cancel. So we have negative x squared minus 4x is g of f of x. So now it says to find g of f of negative 2. So if you see that, all you're going to do is take this equation you have here of this function here and plug in the negative 2 inside. So let's do that. We have negative 2 squared minus 4 times negative 2. So now we have negative 4 plus 8, so the answer is 4. So try out these examples down here. Find f of x equals 2x, given f of x equals 2x plus 5, and g of x equals 4x squared plus 1, find the following. So find f of g of x, g of f of x, and then C, find f of g when it is negative a half. So pause the video and try this out. If you tried this out, you should have gotten 8x squared plus 7, then 16x squared plus 80x plus 101, and you get 9. So example 6, finding the domain of a composite function. Find the domain of f of g for the functions f of x equals x squared minus 9, and g of x equals 9 minus x squared. So we're going to practice doing what we did before. F of g of x equals, so we have f, and then the g of x is square root of 9 minus x squared. Then we're going to take this 9 minus x squared and we're going to plug it in here. So this becomes, parentheses, square root of 9 minus x squared raised to the square minus 9. So let's stop for a minute. Before we simplify, let's look at the domain. So we're going to look at the domain once we plug it in. So it's this and not looking at what we started with. Okay, so again, we're looking at the domain when we plug it in for the first time before we simplify. So looking here, can we have, well, what is our domain? Well, we know here, inside the radical, that always has to be positive. It doesn't matter if we square it. We have to think about order of operations. We have to do the inside first. So we have to think about the restrictions there. So this is similar to some of the other things we've seen before. We know that the domain in this case is that it has to be from -3 to 3, because that is in the square root. So let's finish simplifying. So we know that the square cancels this out. So now we have 9 minus x squared minus 9. And so the final answer of f of g of x, or the final function, is just -x squared. Now looking at this, it looks like we can plug in anything we want. But again, we have to go back and think about, once we plug everything in, what are the restrictions before we simplify? So in this case, the domain is -3, 3. So let's try the next example, or go ahead and try this next example. Find the domain of f of g for the functions f of x equals square root of x and g of x equals x squared plus 4. See if you can try this out. So looking at this case, again, you want to look at, once you plug it in, what is my domain? So looking here, we have this x squared. Now, it's okay that we have the square root of x. We have to plug it in first before we look at our domain. So what we notice is we have this x squared plus 4. We know it can't be negative, but because it's x squared, we know that it will always be positive. So this is okay. So that means it's all real numbers, or -infinity to infinity. Now let's do the example where we flip it. What if we did instead g of f of x? G of f of x. See if you can figure out that domain. So taking a look at this, before we simplify, we want to look at it before we simplify, after we plug it in. What is our domain? Now looking here, we have square root of x, and then you square it. So before we square it, we have to take care of what's inside, right? PEMDAS, or grouping. And we know that x, in this case, has to be greater than or equal to 0. So in this case, our domain is going to be 0 to infinity. So notice that it's different. So in one case, we get -infinity to infinity for our domain, and for the second case, we get 0 to infinity. So that is the difference with these two. We don't look at the beginning. Instead, we look at what is our domain after we plug it in, for the first, right, immediately, and before we simplify. I hope this helps out. Thanks for watching.